So you might remember me from last year where I talked about Ubuntu Asahi here. This time I want to expand the scope a bit and talk about the general state of Ubuntu Desktop on ARM64. So this will include Ubuntu Asahi, but also a few new things. If I asked here, who of you has used or seen Ubuntu Desktop running on an ARM machine, I'm pretty sure there's quite a few of you who have. And what you're likely thinking of is something like that. A small single-board computer, maybe a Raspberry Pi. This has been around for, well, a while now. I was told we've been shipping desktop images for Raspberry Pis since Ubuntu 2010, Groovy Gorilla. The flavors had images even before that. It took a time for hardware to catch up with the requirements of our desktop. More lightweight desktops worked before that. This is not actually what I want to focus on today, even though it's still part of the ecosystem and profits from a lot of the things I'm talking about. So what I actually want to talk about is desktop hardware, proper desktop hardware, that has only become available in the last few years, right? This started with Chromebooks adopting ARM. There's a ton of cheap MediaTek Chromebooks out there today. And then in 2020, Apple started switching over to their own silicon chips. And those are probably the most widespread ARM devices, laptop devices we have today. And there's new exciting developments we're seeing. Windows on ARM is slowly catching up. There's new Qualcomm platforms for Windows on ARM that are widely available. If you look at the current Snapdragon X Elite release compared to the previous one, there's like a ton of manufacturers that build laptops with this chip. So what has changed in the last, let's say, 4 years since we have our Raspberry Pi images is you can actually buy an ARM64 computer or laptop. I would have put the System76 one on the slide if I had known about it. But the slide was done before I learned about this. But very exciting as well. So let's look at the current state. We just released Ubuntu 24.10 Oracular Orioli 2 weeks ago. What a release. Tons of awesome improvements. GNOME 47 fixes fractional scaling. We have a bleeding-edge Linux kernel, which is always exciting for us running on the latest hardware, right? Permission prompting, apt UI improvements. But something we haven't been very loud about that also happened with 24.10 is, if you look at our cdimage.ubuntu.com website, there is an ARM64 desktop image that popped up. And this is something entirely new. We did have images for specific hardware before. This time we're trying something different. We're having a generic ARM64 installer. But what is generic? What is even supported here? So currently, this should work on any generic UEFI and ACPI machine. It will work in most virtual environments. I've talked to people who use Ubuntu on Macs in a virtual machine. If you previously had to install a server image and then install desktop packages, you don't need to do that anymore. You can use this. And then if you've been at the summit or listening to the talks last year, you might remember our Ubuntu Concept for the X13S ThinkPad. So everything we learned also went into this image. So it also just works out of the box for this hardware platform. And this brings us closer to where we want to get in the future. I think one thing we need to improve on in the ARM ecosystem for laptops to work better is we need to reduce the entrance barrier, right? We need to make it easier for you to just install Ubuntu on your machine and run it. And something we have announced very recently, just after the Oracular release 2 weeks ago, is a new Ubuntu Concept for 24.10 targeting the Snapdragon X Elite platform. And this time, different than our previous Ubuntu Concept, we are not targeting a single laptop. We are instead trying to target the entire Snapdragon X Elite fleet. and try to get as much of this working as we can. This is currently working, but very bleeding edge, and mostly suitable for developers and enthusiasts, which is why we call it a developer preview. And the goal here is to bring the community together and give them something to get up quickly, to test quickly, and ship the latest features and shorten the feedback loop. Right. So one problem we have is things are getting committed into the kernel. But how do you test them, and who tests them? So we hope that we can contribute by making this image readily available and get more people to actually test the latest changes. And then get the feedback we gather back to the developers, back on the mailing list, and getting involved in the development. It also allows us to experiment with our generic image and try new approaches to make this work better. And this whole thing is meant to be very community-centric. We want everyone to be able to contribute, and we want to reduce the barrier as much as we can. So one thing we did is we asked our community to help us figure out the device information on some of those devices. Because when we started, we were kindly provided a ThinkPad T14S Gen 6 by Lenovo, which I have. But that's only one platform, though. So I went out and asked the community to help me figure out how those other machines look like and what we need to get them running as well. And the responses we got were amazing. Like we now have, I think, 10 hardware devices checked in a bug tracker. We have people coming in telling us the info we need to make the installer just work out of the box. We also have people coming in telling us which patches we might need to cherry pick to get those working in our kernel tree that we use for this particular image. And the most exciting thing is we've seen upstream contributors come in and help others, like the people who actually contributed support for some of those laptops, come into a bug tracker and help users sort out their issues and then learn from what they see there, what is reported by the users. So in just under 2 weeks, we went from one supported laptop to 5 platforms, whereby supported more like working, right? What I'm talking about here is something that boots into your live environment. You have a working live environment, and then you can go through the installer, install an Ubuntu system, and it boots up and you can use it. There's still features missing, of course, like it's very bleeding edge. We don't have audio support on all of those machines. There's a few peripherals we need to sort out. But still, I think for just 2 weeks on bleeding edge hardware, this is amazing, and I want to thank the community very much for making this possible, because this is mostly the community's work. Now, another hardware platform I'm very excited about is Apple M1, M2. I am also a developer in the Ubuntu Asahi community. As I said before, last time I presented our current state. So here's a little update on what changed in this ecosystem. In terms of feature support, we do support everything M1 and M2, all the machines you could get. We do not support M3s at this point. A few features were added since I last spoke about this. The most exciting ones are speaker support. Thanks to the Asahi Linux team, we have excellent speaker support. I'd say it sounds just as good or better as it does on macOS, on those platforms. It uses pretty advanced post-processing and active speaker safety management to drive those speakers as good as we possibly can. We've added HDMI support, which is, I guess, quite exciting, something a lot of people have been asking about for external displays. And another more recent addition is a ton of improvements in the graphics space thanks to the amazing work of, among others, Alyssa Rosenzweig and Asahi Lina. We've got Vulkan working. We've recently added OpenCL support through that. And our OpenGL support is also excellent. There's a few things that don't quite work yet, which I want everyone to be aware of. This is USB-C display support, the built-in microphone, Touch ID, and Thunderbolt are not yet there. But even then, I would say this is like the most feature-complete ARM platform you could buy today, which is very cool because it's entirely community-driven. So I want to quickly talk about the Ubuntu-specific improvements we did in the last year. One of the things we added is this beautiful first setup. After installing your initial installation, you are dropped into this menu that allows you to click through something that looks just like the Ubuntu installer, set up your time zone, language, user. So we've made the entire flow a lot nicer, I think, for the average user. Previously, you had to configure your system by hand on the terminal. I think the Asahi Fedora folks have had this for a little longer. But we really, so this is something coming from Ubuntu that we enabled in our images, and I think it's pretty cool. We also added support for Ubuntu 24.4.1, so there's images for those available on our installer. 24.10 updates work and are enabled. And one of the most exciting additions is GPU acceleration in snaps. Those are generally a little tricky to get right because a lot of snaps tend to bundle Mesa. And we are on bleeding edge hardware. We need a patched version of Mesa itself. In 24.4, we solved this by having a Mesa content snap and a new GPU interface. And our Mesa content snap has a separate channel for our Asahi Mesa drivers that we pull in automatically on those machines. And for user, snaps will just work perfectly fine. And I think that's very exciting, even though it's by design very non-exciting. But that means stuff just works. If you want to try this, here's a QR code to our website with more info on Ubuntu Asahi. I will also show a link later again. I've talked mostly about positive things and improvements, but I want to be a little more self-critical, right? Let's talk about a few things that are not great yet, a few things that we need to improve on to make this as good as the Intel experience is today. And the first question I want to ask is this really generic? I said we want to build a generic installer image, but is it really? And the truth is, we try to make it as easy for you as we can, but we do need to employ a bunch of tweaks to make this work. And that's because on the hardware side, on the firmware side, the ecosystem is still very fragmented, right? And not just that, there's also problems upstreaming changes into the mainline kernel, and a few of hardware-specific tweaks we need to make for each of those platforms. One limitation worth noting here is, for example, that for the Snapdragon platforms, but also for Asahi, we don't have a proper solution for secure boot yet. We use device trees per machine device trees on each of those, and we don't have a way to sign them in grub. It works, so this is not as much a problem on the Asahi side, but certainly on the Snapdragon side, where the devices themselves don't give us a device tree from firmware, so we have to handle this as an operating system, which is not the way it is intended to be, but that's what we have today. So I think we are very early here in terms of the ecosystem, and I hope that standardization will solve some of this. Another one I want to talk about is we are hitting bugs, and I'm sure not all of those bugs, or many of those bugs, are not because of ARM or because of Asahi, but they are because we're doing things differently than they were done before. On the Apple machines, we're hitting bugs because we're using a non-standard page size in the kernel. There's also bugs coming from non-uniform CPU cores, and a lot of things that are about to become a thing, but we are at the forefront, so we're hitting them first. And I believe that there's also a bootstrapping problem here, where there's just less testers on those platforms, so you're more likely to be the person hitting the bug. So how do we solve this? I think there is not one real proper solution to this, other than making hardware more available, getting it into people's and developers' hands, and making sure everyone catches those early, right? So we basically need to get more eyes onto things. And that brings us to the next one. I think we have another bootstrapping problem. Can you guess what those apps have in common? They're not available on the Ubuntu store for ARM64. But in fact, Chrome is a bit special because it's not available for ARM64 at all, right? I guess the same goes for Steam. Some of them are just not available as snaps, even though you can download them for ARM64 from the vendor's website. Chrome is a huge blocker because it is what we would need to enable DRM video content. So if you're into watching Netflix, that is not something we can do today, or not easily do today. And I think many of those are actually a blocker for professional usage. So if you look at the bigger picture, people like to think the software situation on Linux is way better for alternative architectures. And that is right in a way. Specifically, if you look at binary packages from our archive, we can see, well, RISC-V. I included RISC-V here because it's an even newer platform, right? RISC-V, ARM64, x86 are very close in terms of support, very close to 100%. In snaps, the story looks entirely different. So this is, by the way, based on public data. Popey did a Mastodon post last year where he looked at snap support through the public API. Numbers might be slightly off, but I think it's the best we got to work with. And what we're seeing here is, for us as Ubuntu, it is easy to enable new platforms because we just flip a switch in Launchpad, right? We willingly gave that control to the publisher in snaps. Same is true for all other channels of where the publisher controls distribution, right? And they might not be as passionate about new hardware as we are. So what can we do to improve the situation? There's something we already do. We provide Launchpad builders to build your snaps in our build farms, and you can do this on ARM64 as well as you can do it on x86. I think there's room for us to improve and incentivize publishers to also include alternative architectures. And I think we might have to improve our documentation and our defaults to make sure this is what anyone does by default, right? So you should have to opt out to not have an ARM64 version of your software. There's also something positive to see here. As I said, RISC-V is even younger, and we see ARM64 is, I think, at 37% availability. So I'm pretty sure it was way worse like 2 or 3 years ago, and we see ARM64 ramping up, even though I wish it would go faster. And now let's look at something positive again, exciting new developments. We have Neil from Asahi here today to talk to give you all the details about this at a booth later. There are people out there who are pushing the boundaries of what we believe is viable and possible today. And just, I think a week ago, or maybe two, Asahi announced AAA gaming on their ARM64 platform. And I think this is very exciting. And what they're doing is they're emulating x86 on ARM in a VM, because they're also emulating 4K pages on a 16K page native kernel. And they're also emulating Windows compatibility, because they're running Steam and Proton. And this all works, right? And this is performant, and this is usable. And what we see here is that we are one big community, and we are pushing boundaries in those community projects. But I'm pretty certain that all of what we learn there will come back into the ecosystem. And it's something we can utilize to make everyone's experience better. So I'm pretty sure that what Asahi has been doing here is going to be leading for other distributions. And we will see a lot more of this in the future. So a quick outlook. A very similar stack. So the emulator they used to run x86 on ARM is called FAX. FAX is on GitHub. They built a PPA for Ubuntu, so Ubuntu is a target platform for them. And I actually gave it a try on my Snapdragon X Elite platform. And it turns out it just works. I can run Portal, I can run Steam on a new Qualcomm laptop. And I think this is exciting. This is the way forward. This might even solve a bootstrapping problem to a certain degree. I've heard people didn't bring their laptops because, I know, their note-taking app didn't work. So maybe we might have a solution at hand here. And I think we should try to get this into Ubuntu, try to make it accessible, and find ways to integrate it in a way that stuff just works for our users. And this brings me to the end. I put a few links on here, both for the Apple Silicon side, our Ubuntu Asahi website, Asahi Linux, ISC channels we are on, as well as information on our Linux and Snapdragon projects. Please visit those. And I want to ask you, if you are interested in this topic at all, please visit us at our booth later, after the lunch break, because the next two talks are very exciting as well. And please get involved in our projects. We are community projects. We are always looking for contributors. And if this sounds interesting to you, and if you're into ARM64, I think we'll be happy to work with you. Thanks. I think we do have a bit of time for questions, if anyone has any.
This was really interesting, and I have a technical question, and just basically know nothing about it, so tell me anything you can. What do you see the end game for the page size? Do you think that's going to converge on something, settle on a pair, or there's going to be some phenomenal solution that makes it irrelevant?
I think the end game would be for the kernel to be able to handle this per process, or more transparently. That is not something that is possible today. On the Apple platform, we are using a 16K page size because that is what the hardware is built to do, right? That's what the IOMMU operates on. So you don't want to run everything in 4K. So that's not something Linux can easily do today. So I think this is really on the kernel to grow support for being more fluent when it comes to page sizes. But I think we will see more diversity there. I think the newest Raspberry Pi by default also ships with a 16K page size, and we do have servers on 64K pages. Again, I think we're very early in this space, and we need to wait for solutions to develop and applications to become aware as well.
Thanks.
So my question is, what exactly prevents laptops that have ACPI support to boot using built-in ACPI in software rather than per device DTB?
Okay. That very much depends on which laptop we're talking about. In the Qualcomm case, the way they are using ACPI is very much not compatible with the Linux implementation. So Upstream decided to go for DTBs instead. There's nothing on a sane platform preventing you from doing that.
Okay, so
It's just like we don't have hardware that properly works like that.
So another quick question. How do you feel to have a virtual character as your colleague?
Can you repeat that, please?
How do you feel when you have a virtual character Asahi Linux as your colleague?
How do I feel?
How do you feel?
I think that's exciting. I think her streams are impressive. Every time I watch them, I learn something, and I'm humbled to have such smart people working in this space with me.
Okay, thank you.
Thank you, everybody, and thank you, Tobias.
Thanks.